Hello there. In this video we're given some measurements and we want to know if these two resulting triangles are going to be similar or not. So start with drawing scalene triangles. And the only way, we have no angles in this one. If they are going to be similar, it's going to be by side, side, side. The only way that they can be similar is if short matches with short, medium with medium, and long with long. So in the blue triangle, I have a short of 12, that's this one, and then a medium of 18 and a long of 21. And in the red triangle, I have a short of 20, a medium of 30, and a long of 35. And now let's test out if these proportions work out. So short over short, medium over medium, long over long, these are both divisible by 4, and we get 5/3. These are both divisible by 6, and we get 5/3. And the last ones are both divisible by 7, and we get 5/3. So that one test checks out. And then we can write them in order. Actually we need the letters still. Yeah, the letters are very important. Okay, so the short is BC. Now this little point here, that has to be between the short and the long, so that's between this 12 and this 21. The letter that's in common there is C. So that's going to be C. This one up here, that's between the 12 and the 18, and the letter in common there is B, making this over in this corner A. And once over to make sure all that checks out. AB is 18, BC is 12, AC is 21. Okay, very good. And over here, between the 20 and the 35, so there's the 20 and there's the 35, that common letter is Z. Between the 20 and the 30, that common letter is, 20 and the 30, common letter is X. And over here, that's got to be Y. So XY is 30. YZ is 35, and XZ is 20. Okay, so now we got them in order, and we know that these check out. So we can write the statement, triangle ABC. I did that one in alphabetical order. Normally I go around the path, so I'm doing ABC this way up this way. So that's going to be similar to triangle Y, and then up the path to the B, XZ, by side, side, side similarity theorem. Okay, we got that one. Next one's going to be a little bit scrunched here. Draw your scalene triangles. I'm going to put them right beneath. So I actually changed the order here. I got short, medium, long. I saw this 25 here, and I kind of like putting that in this corner, but it doesn't really matter. So, matching up the parts here. It's good if those angles match up, so I'm going to make that both P and M. And now, looking at these letters, I got PQ and PR. So this one, PQ, that's a little bit shorter, so I'm going to make that this length up here, so that's going to go up to Q. And over here we're going to have PR, and that's going to be the 20. Now on the other side, I got MN, that's the long one, so that's actually going to be down here, that's 25. And OM, so there's O up there, that's going to be the medium one, that's going to be 20. I suppose I don't know that this is shorter than either of those. It could wind up being longer, but the 25 degrees, it's a pretty good guess that that's going to be shorter. The important thing is that we got the longer version on the bottom and the shorter version of these on the top. And, well, the 25s match up, so that's pretty good. Check out the ratio of the sides. 20 over 16, both divisible by 4, that's 5/4. And 25 over 20, also both divisible by, this time 5, and we get 5/4. So there is the scale factor. And then we can write that triangle, PQR. So I'm going this path around it. That's going to be similar to triangle MON by side angle side similarity theorem. Suppose we could mention up here this was also a similarity theorem. And just glancing at this one, look, we got a scale factor of 2, scale factor of 2, 60 degrees. I mean, this one's got to be side angle side, right? Okay, draw the picture. Now, I could decide where I want to do the 10 and the 8. Maybe I want to work off of that 60 degrees first. It's always kind of nice to put the angles in the corner. This doesn't quite look like 60, but we'll be forgiving on that. So there's the 60. That makes this E. And I have ED and DF, so I don't really know which one's which. We might as well make this D here. So that's going to be 10. And that would make this F over here, and we know that that length is 8. Now in the other triangle, let's match up our 60 degrees. That's going to be H. And to keep things kind of matched up over here, now notice I actually have angle side side. Keeping things matched up over here, HJ, we can make that the 16, so maybe this is J over here, and this will be JI, and we can make that one 20. So this one actually falls apart on a couple different accounts. Number one, in both of these, we don't have side angle side. We got angle side side, and that's not a congruency theorem. And number two, the 10 is matching with the 16, and the 8's matching with the 20, so we don't have a common scale factor between them either. So in this one, we do not know if they are similar. It could turn out that they're similar, and that is certainly a possibility. Or actually, is that even a possibility in this case? It's a good question. Might have to check things out. We're going to just conclude that there's no conclusion on this one. We don't know if they're similar or not. They probably, I mean, they don't have to be similar, so we cannot reach a conclusion. It might turn out that they can never be similar, but I'm not quite sure about that. Anyways, that's not important. No conclusion possible. There's no angle side-side similarity theorems, and besides that, the ratios don't even match up for how they're matched up with each other. So, we thought that it might be doubling there, side angle side, but when we actually sketched the picture, we saw that we were winding up with a very different situation, and that's why you have to draw the pictures for these. Thanks for watching. Character and Scholarship for Life.